Okay, last topic here, stability. Stability. Okay, what is stability? What is stability? Why do we need to know the stability of our system? Called the stability, the ability of system to stabilize to one point. Okay, at one point. Okay, in graph, for example, in graph, okay, let's say we can divide stability into three group. First is stable. Second is unstable. Stable. Third is marginally stable. Marginally. Marginally stable. Okay. For stable system, okay, let's say we have this graph. F T times. Okay, let's say we have a system function lah. Contoh macam ni lah. Okay, system go and do. Okay, then it will start to decay. Decay. We start to decay, decay to 0. Okay, at t equal to infinity lah kat sini. Approaching infinity, our function decay to 0. So this is what we call stable system. For unstable system, let's say we have a function like this. Okay, go to infinity. Infinity, different also infinity. Okay, third one is marginally stable. Okay, marginally stable is not go to infinity and not go to 0. Okay, for example, it's just consistent. Okay, not go to infinity, not go to 0. Okay, is it clear what is stability? So for this system, so we want our system is stable lah. Mesti kita nak stable kan. So definitely we want our system stable means that we want our system decay to infinity. Sorry, decay to 0. Decay to 0 as time approaching infinity. 0 lah. Tapi bukan 0 sampai ke infinity baru di 0. So it's stable. So it's stable system. Okay tak?
Okay, Prof.
Okay.
Okay, sir.
How to define our system is stable or not? How to define our system is stable or not? So we can use transfer function. We can use zero and poles. Normally, we will use zero and pole. Okay, to check our system is stable or not, we check the poles, the value of poles. This poles. Value of pole. This pole, the value of pole. Value of pole. We check the value of pole. This pole. Okay, when we plot our system in S domain, S plane, so we will know our pole here. For example, for this example, our pole is at -3 and -4. Okay, -3 and -4. So for system at -3 and -4, the system is stable. Yeah. For stable system, our pole equal to negative. Okay, negative value of poles. Pole must be negative. So our system will be stable. Pole negative, less than 0. So our system will be stable. If our system is positive, is our let's say for pole positive, our system will be unstable. Pole greater than 0. This one is if pole equal to 0. Means that if our pole at this side, our system will be unstable. If our pole is at this as this, our system will be marginally stable. Okay, how to check it? We just check our equation. This equation, from this equation, we can know from this part, bottom part, denominator. From this denominator, we will know value of poles. Whether it is negative or positive. If a value of pole is means that all pole must be negative. All pole must be negative. So system will be stable. If just one pole positive, so system is unstable. Okay, dapat tak? Okay tak ni?
Okay, sir. Okay.
Example, sir.
Prof.
Example.
Okay, example. Okay, example. Okay, I will give example here. Why? Okay, why? Okay, what is the relation between stability and poles? Sebab apa poles? Okay, for example, let's say our GS is equal to 1 over S plus A. I just take one value only for the example. So from this one, what is the value of pole? Equal to minus A kan? Okay, pole minus A. Betul tak ni? So now is in the plus in S domain. So in T domain. Okay. For T domain, what is the value of F T equal to? Convert to T domain. E kan? E minus AT. Okay. This one is equal to E minus AT. Oops. E minus AT. Okay tak? E minus AT. Dapat tak?
Dapat, sir.
Laplace transform. Laplace transform. Wait, sorry. Inverse Laplace. Inverse Laplace for 1 over S plus A equal to E minus AT. Okay. So we try plot it. Let's plot the graph. Okay, A. So first, A greater than 0. So our FT will be equal to E minus AT lah. So when we plot it, FT T. Okay, this one is E minus, we will build this graph untuk E minus T. Okay tak? Betul tak? This one is, we plot is E AT. Okay, this will call decay. Okay, so our system will be, this one is stable. Decay. Decay our system stable, decay to zero, kan? In T domain, we get this kind of equation. So from this equation, we plot into graph. Okay, graph will be like this. So our function will approach to zero when time equal to infinity. So system is stable kan? Stable. Number two, if A less than zero, okay, what happened? If A less than zero, means that our Ft equal to E minus A less than zero kan? A less than zero maksudnya means that A minus zero lah. A negative lah. Is equal to E AT. Okay? EAT. If A negative. If A negative, so E power of AT. So when we plot this equation, our graph will be like this. EAT. Okay. Okay, from this graph, we can say that at this condition, our system is unstable kan? Why unstable? Because this one, number two. Ft approaching infinity when t approaching zero. Okay? Our function will go to infinity when t go to zero. When t go to infinity, our system go to infinity. For stable system, when t go to infinity, our system go to zero. Yeah, this one. T go to infinity, our system or function go to zero. Okay, for unstable, t go infinity, our system also go to infinity. So for case number two, if A minus, if A minus means that our system unstable. Okay. For case number three, A equal to zero, our Ft equal to E power of zero equal to 1. So like this, 1. So for that one, our system will be marginally stable. Not go to infinity and not go to zero. It just always 1. Okay? So marginally stable. Okay, for this case, for third case, our system is marginally stable. Okay, so from this three example, we can say that to make our system stable, pole must be negative lah. So pole must be negative and must always at this side, left hand side. Okay, pole must locate at left hand side. So our system will be stable here. Stable. If value of P is positive or this side, value of P at this side, unstable. Our system is unstable. If the value of P is on this line, or we call 0, is marginally stable. Okay, is it clear? The relation between stability and poles. Yeah, because when poles, okay, when pole positive, the graph will be like this. Pole positive, pole positive. Pole negative, graph will be approaching 0 when time equal to infinity. Okay, so we try to do one example last. Now it's 6:30 already. One example. Okay, let's say our GS equal to S plus 1 over S power of 2 plus 4S plus 3 lah. Okay. We check whether the system is stable or not. Check the stability. Stability. Okay. Can you check the stability of our system? Okay, first we factor it. So GS will be equal to S plus 1. Okay, denominator. What's the denominator? S plus 1, S plus 3. 1S, 4S, okay. So, then we plot it in our S-plane. Real, imaginary. So our 0 is, okay, what is the value of 0? We take this one, 0. 0 is minus 1. Pole is minus 1.
Minus 3.
Minus 3. Okay. Okay, 0 is here. Minus 1. Pole also here. Minus 1. Okay, the next pole is here. Minus 3. Okay, minus 3. Okay, so we can say this is our system is stable. Why? Because P is negative and all the P locate at left hand side. So our system will be stable. Okay tak? Just
Okay.
check the value of P. Okay.
Okay, doctor.
Okay Okay, now let's prove it. Nak prove tak? Nak prove? Nak prove cara ni tak? Nak prove? Okay, we want to prove it. Okay, want to prove it. So first we find we want to prove it. We have to convert into T domain. Convert to time domain. So from time domain, we plot the graph. So we check the graph whether our graph. Okay, we check our graph like this or like this or like this. If our graph like this, so our system is stable. If our graph like this, the system is unstable. Okay. To prove it, we have to convert to time domain. How to convert to time domain? How to convert to time domain? S plus 1, S plus 1, S plus 3 equal to partial fraction A, S plus 1 plus B, S plus 3. Okay tak? Partial fraction.
Okay,
So,
sir.
okay, partial fraction. Sorry, okay. All right. So now equal to A S plus 3 plus B S plus 1. This one is S. If we potong, we will get 1 over S plus 3 kan. So 1 over S plus 3 E minus 3T. So our graph will be like this. Okay, so stable lah. Betul tak?
Yes,
This one is S domain. This one is time domain. So from time domain, we plot a graph, we will get, our graph will be, so graph E, E exponent minus. If exponent minus will be decay to 0.